Hello everybody. This is my lesson on 10.7 out of your math book, and the objective here today is to find the area of composite figures. A composite figure is a shape or a model that's made up of shapes. And what you're going to do today, first and foremost, and I can't emphasize this to you all enough, is make sure you stay organized. But if you've had a chance to view my other videos for previous lessons, you have everything that you need to solve these problems. The thing is that you're not going to have one set shape today. Like for instance, the practice problems that I'm going to show you, you'll never see on the assignment because there's so many different kinds of shapes that you can make. So I'm just going to give you the strategy in which to solve each one, and you need to break it down into shapes that you recognize. So if you see this particular shape, when I look at it, I see a triangle and I see two rectangles. And what I'm going to do is find the area of each one. So if you have saved your formulas from other assignments, this is the chance now to bring them out and use them. And as I said before, when it comes to certain formulas, for instance, the triangle, kids forget to do certain things. Like in a triangle, they forget to divide by 2. So what I'm going to do is just simply break this down into stuff that I recognize, and again, stay organized and just calculate it out bit by bit. So the first thing I see is a triangle, and the area of the triangle, I know is base times height divided by 2. So the base of this triangle is 3, and it says the height over here is 4. So 3 times 4 is 12, and don't forget to divide by 2, and 12 divided by 2 should be 6 feet. And we're going to have it squared because, again, we're finding area. Now I see a rectangle and a rectangle. And forgive me again, I can't draw very well, but the rectangles, if you look at the measurements, are supposed to be congruent, meaning same size, same shape. So I know if I find the area of one rectangle, it's going to be the exact same answer for the other one. So I'm just going to use this rectangle right here because the numbers surround it. They're nice and close to the sides of the rectangle, and we're going to calculate that out. So the formula for finding the area of a rectangle way back from the beginning of the chapter is base times height. So base times height, 5 times 10 would be 50 feet squared. And I know that this other rectangle here on the left has the exact same area. So I have 6 feet, 50 feet, 50 feet. Now to find the total area of that particular shape, all I'm going to do is add up these areas together. So I know 50 plus 50 is 100, and 100 plus that final 6 feet is 106 feet squared. And remember to put that exponent of a 2. As always, you're finding out how much space a two-dimensional shape can take up. In this case, it's the unit being used as feet. So what I did is I took each shape, I broke it down, found the area of each one. That's how I got these numbers down here. And to find the total area, I simply added them up, add on the label of feet squared. So 106 feet squared is the area of that composite figure. Another one. Sometimes you're going to be given numbers into shapes that are there, but they're meaningless to you. So for instance, if you look at this shape right here, you have a couple of shapes that you recognize. I see triangles and I see a rectangle. Now remember with the triangles one, if you watched my video, I think it was last week, when it comes to area of the triangle, you never ever pay attention to the slant. And the slant in this case is the 13 meters. So I'm just going to cross that out, because I don't need that in my calculations. And my students know me, I'm a very visual learner, so I have to see what I'm learning, and I'm going to cross those things out. The other thing is that sometimes numbers are not going to be very well placed for you, and what I mean by that is that sometimes you're going to have to use information in other parts of the model to figure out what certain measurements are, and this shape does that. So from here, we have the height of 5 meters, which, yeah, that 5 meters is perfectly placed. It's easy to see. But the question is what is the measurement of all this? Because we're supposed to find the base of a triangle. So what I'm going to do is kind of look around the shape and see if there's any other numbers that can help me solve what the distance is from this mark to that mark, because I know 6 meters is from here to here and 6 meters is from here to here, but where do I look to find the distance between the two? And I'm going to look at other parts of the model. So when I'm going to look around, I see a 7 meters, and that represents this line going vertically, and I see a 12 meters, which represents this line going horizontally. And when I look at this, I know that the distance from here to here is the same distance from here to here. So that tells me that I'm going to use 12 meters up here in my measurement. Okay, so sometimes you might have to look at other places in the model to figure out what measurements are going to be. So again, breaking this down, I see a couple of triangles, and again, these triangles are supposed to be congruent, same size, same shape. So when I find the area of one triangle, I can find the area of another. So I'm just going to do this triangle right over here on the left. So I know the height of this triangle is 5. Now the base of it is not all the way across, it stops right here. So I know from here to here is 6 meters, and if it goes all the way across 12, if I split that in half, I also know that this is 6 meters. So I'm going to get rid of this because it still equals the same thing. So what I have from here to here, the base of this triangle, is 12 meters. 6 plus 6 from here to here is 12. So if I take 12 times 5, which is base times height, I get the answer of 60. And when I have to do the area of a triangle, I have to divide it by 2. So 60 divided by 2 is 30. So I know the area of this triangle is 30 meters squared. And again, these triangles are congruent, same size, same shape. So I know the area of one is the area of the other. So that takes care of my triangles. And the last thing that I need to do is find the area of this rectangle. And the formula for finding the area of a rectangle is base times height. So 12 times 7. 12 times 7 in my head comes out to be 84 meters squared. So the last thing that I need to do to find the total area is take all these numbers and add them. So I know 30 plus 30 is 60. And I'm going to add 84 and 60. So 4 plus 0 is 4. And 8 plus 6 gives me a sum of 14. So the area of this composite figure is 144 meters squared. So remember, sometimes in the models you're going to have to look at other measurements to help you solve missing measurements. So everything will be there as far as a clue. You just need to make sure that you're following formulas carefully when you're breaking down each individual shape. So the last thing then that you'll see as an example on your assignment is something that's going to look like this. Now, they're going to ask you to find areas of shapes, but sometimes those shapes are going to have chunks taken out of it. So what I did here is I took this rectangle and I've shaded around the chunk that's taken out. So in other words, it's kind of like a square donut. So what you do here is a little bit different, not much, but you still have to find formulas or use formulas to find the areas of things. So again, I see two rectangles here. So what I'm going to do first is find the area of the whole rectangle that's the larger one, as if nothing was taken out of it. So when I look at this, base times height is how to find the area of a rectangle. So 12 times 8 would come out to be 96 yards squared. That's the whole thing. Now we have to complete the problem though and find the area that's been taken out of this chunk. And it's the same thing, it's a rectangle, base times height. So 6 times 4 is 24 yards squared. Now, what makes this particular problem different is that the last step in the previous problems I showed you, you're used to adding. Well, what happens, ask yourself, what happens if I have a whole thing, but I take part of it away? And when I use that kind of language, take part of it away, what process means to take something away? And I'm hoping you're thinking to yourself, it's subtraction. So I'm just going to go the larger rectangle, 96 yards squared, minus the 24 yards squared, which is the chunk that's been taken out. When I take 96 minus 24, it does not look like I have to borrow. So 6 minus 4 is 2, and 9 minus 2 is 7. And so now what I'm representing here is that I have just found the area of the shaded part that remains. So all this that I colored in here, if I were to put a square unit down, in this case it is yards, 72 units, 72 yards, square yards would cover this without any gaps or overlays. And so when you're asked to do that on the assignment, to find the area of a shaded figure, instead of adding everything up at the end, you'll probably have to subtract to represent that chunk being taken out of the composite figure. So as I said earlier, it's not where you're going to see these shapes again. It's more about the strategy. Again, the strategy is make sure that you see shapes that you recognize, and you've done squares and rectangles, you've done triangles, you've done parallelograms, you've done trapezoids, and then follow those formulas carefully. If you need to go back to previous videos to find formulas, please do that. You can always Google stuff for formulas. You can use calculators on this, but just make sure you understand what you are breaking down. And as I said on the previous problem, which was this problem right here, is sometimes you're going to have numbers that mean nothing to you as far as area. Sometimes you're going to have to use other measurements in the figures to find measurements that are missing. In this case, we brought that 12 up here to find the distance from here to here. But if you just take your time and break it down, this assignment is not too bad. Just make sure you follow formulas very, very carefully. So as always, please email me if you have questions. If you need to request a Zoom, that would be great. But just give me a shout out if you need help, and we can work on this together. Enjoy your day. Hope you're having a good one, and take care of yourselves.